Okay, now we come to a highlight of the event, and that is we're going to be doing student awards. But first, before we actually get into the student awards, 2 days ago we had a business plan competition, and we have about a 2-minute video, a summary of that competition. So first we're going to watch the video, and then we will proceed with the awards. Please, video, please.
Global Grand Challenges Summit starts with the students. The Grand Challenges are actually for you guys as well. It's a big project for the new generation.
They're called the Global Grand Challenges for a reason. I don't think that it's a challenge that any one country or any one group of people can solve on their own. It's definitely something that needs to be collaborative.
If we share our ideas, maybe we can create some better things together.
I think it's a great honor that we were able to come this far and represent the UK.
It's a great opportunity to meet other people from industry and from other unis. Like the whole event is 2 days and you've got some big name companies showing up.
From this competition, if I've learned anything, is that everywhere around the world works completely differently. And I feel that bringing engineers from different parts of the world, you're going to get different answers.
For the first time, you find yourself working in a room with people that are as motivated as you are, like who are really there not just for like lectures and getting a degree, but rather for like making something. And all of us are problem solvers, all of us want to help people, and engineering is really the best way, I think, that people can do that.
So to present the awards today is Mr. Ron Makoske. He is the Senior Vice President of Corporate Engineering, Technology, and Operations for Lockheed Martin. And I do want to say that Lockheed Martin is one of our principal founding sponsors of the Global Grand Challenges of Engineering, and they have been partnered with the National Academy of Engineering on the Grand Challenges program since 2011, so they have been a terrific supporter of our program. Turns out I actually work for Lockheed Martin. I'm retired from Lockheed Martin, so I know them well. They are a leading global security and aerospace company, and they're engaged in the development, manufacture, and sustainment of advanced technology systems literally around the world, and you can see why they are tied in with our 14 Grand Challenges. Now, Rod is responsible. His job is providing leadership for 70,000 people under him in the areas of technology, engineering production, supply chain, program management, and sustainment. And he also ensures engineering, technical, and operation excellence across the entire corporation. So he has a vast technical engineering responsibility. And I want to particularly thank Rod again for the support of Lockheed Martin for the National Academy of Engineering, our Grand Challenges. And I am delighted that he can be with us today. Ladies and gentlemen, great welcome. Rod, please. And also on the stage is the president of the National Academy of Engineering, Dr. Dan Moat, and he and I will participate in the award ceremonies. Ron.
Good afternoon. Am I on? Okay, there we go. Good afternoon, and thanks, Gordon, for the warm welcome. It's an honor for me to be here to represent Lockheed Martin and at the third Global Grand Challenges Summit to recognize and celebrate the students' achievements and to discuss how together we will engineer a better tomorrow. I'd like to first acknowledge and thank Dan Moat Jr., President of National Academy of Engineering, Dame Ann Dowling, President of the Royal Academy of Engineering, David Tomlinson, Fellow at the Royal Academy of Engineering, Zhou Ji, President of the Chinese Academy of Engineering, Yanis Yortsos, Dean of the Viterbi School of Engineering at USC, fellow sponsors, elected U.S. government officials, engineering students, faculty, and event judges. The Global Grand Challenges Summit brings together the brightest from across the academies, top universities, government, and industry. To the faculty, advisors, and judges, thank you for taking an active role in guiding and preparing the next generation of engineers. To the students, let me recognize all of you for your dedication, enthusiasm, hard work, and professionalism on the efforts we saw during the summit. As you know, the Global Grand Challenges Summit culminates with a competition where teams of students present ideas and business plans for addressing topics ranging from sustainability and health to security and the joy of living. These grand challenges represent the challenges we're all facing across the world and will take true innovation and engineering to solve. At Lockheed Martin, innovation is the lifeblood of our company. Every day, our engineers solve complex grand challenges like you have done in the last couple days. And we need the best and brightest talent like you to enable us to engineer a better tomorrow and to accelerate scientific discoveries from the depths of the ocean to the far reaches of space. For example, we're developing a variety of spacecraft to explore planets and asteroids in our solar system. These capabilities will help scientists and researchers gain new insights about the solar system, the universe, Earth, and life origins, expanding the tools available for scientific discovery. We're building Orion, NASA's first spacecraft designed for long-duration, human-related deep space exploration. Orion will transport humans to interplanetary destinations beyond low Earth orbit, such as asteroids, the Moon, and eventually Mars, and then return them safely back to Earth. Last year, the Juno spacecraft, managed by NASA's Jet Propulsion Laboratory, reached its destination after making a 1.76 billion mile 5-year voyage and got there within a second of the prediction. Juno's mission is to orbit around Jupiter to study the planet's origins, structure, atmosphere, and magnetosphere. On July 10th, Juno flew over Jupiter's Great Red Spot. This was humanity's first up-close and personal view of the gigantic feature, a storm monitored since 1830 and possibly existing for more than 350 years. Also, launched in 2016, the Origin Spectral Interpretation Resource Identification Security Regolith Explorer, or as we like to say, OSIRIS-REx, will rendezvous with an asteroid to study it and return to Earth with samples that may hold clues to the origin of the solar system. These spacecraft require aerospace, industrial, mechanical, electrical, and software engineers, data scientists, and big thinkers to focus beyond what's possible today. We may not know what's going to change the world next, but chances are, like many of you, we're probably working on it today. And that's why I'm here today. Why we invest resources, time, and energy to support the development of engineers like you in this room that will develop the generation after next technologies to solve our world's toughest challenges. We're dedicated to inspiring and recruiting the next generation of scientists, engineers, and innovators. For us, STEM education is a critical focus. We know firsthand the importance of education. We hire about 3,000 engineers, technologists, and mathematicians for our programs and research and development labs every year. Our future success and global well-being depend on a constant supply of highly trained, highly capable technical talent. So now, this is the moment I know you've all been waiting for. I'd like to recognize the next generation of innovators, engineers, and big thinkers on winning student day teams and highlight the best university students' research posters related to the 14 Grand Challenges. It is my pleasure to announce these awards in two categories. First, we'll talk about the business model competition that was held on Tuesday, and then the poster session that was held on Wednesday. The business model competition was chaired by Yanis Yortsos, Dean of the Viterbi School of Engineering at USC, and organized by Andrea Belz, Vice Dean for Technology and Entrepreneurship at the USC Viterbi School of Engineering. The competition was between 15 teams, 5 each from the US, the UK, and China. The first student business model competition was held informally at the first summit in London in 2013. This year, 5 teams from each country were selected, and the 15 teams selected participated in online training that started in April and culminated in July of this year. The teams then presented their 7-minute business model pitches on Tuesday, July 18th, in front of a panel of 7 judges. Before announcing the winners, I would like to acknowledge Andrea Belz, who is unable to be with us today, and ask the panel of judges to stand up and be recognized. I would now like to ask all the student teams to stand up and be recognized. And now, I'm very pleased to announce the winners of the competition. The winner of the third prize of $5,000 is Dreamhouse Group from Shanghai University. The winner of the second prize of $10,000 is More Water from Bournemouth University. And the winner of the first prize of $25,000 is Open Viral Load from the University of California, San Diego. It's my pleasure to now ask the winning team to come forward and give us their presentation, which won them the award. When we're done, we'll take a team photo. Show you as your. All right, congrats, thank you. Good luck.
Do you know where the slide clicker is?
Well.
Right. Well, while we wait for the slides to pop up, I'd just like to say a huge thank you to the National Academies of all 3 nations for hosting this event and having us here. It's been a huge honor, and to all the other teams for participating. All right. We are formerly Open Viral Load student team and now a student-founded benefit corporation, Worldcare Technologies, based in UC San Diego. Our objective is the development and deployment of an HIV viral load test that is accessible, effective, and affordable, lowering prices compared to our competitors by 50% or more. Gotta get a little help changing slides. Is this it? Okay. So, what is viral load testing? Thank you. Viral load testing is a long-term treatment monitoring method for HIV, essentially the gold standard in making sure that patients who are taking their treatment can live a long, healthy, and full life with no risk of drug resistance or of inadvertently infecting their loved ones and further spreading the disease. Today, people like Magic Johnson up here and many others with HIV are living completely normal lives. If you take your treatment every day, the life expectancy of someone who's infected right now is actually 78 years in the United States, which is an incredible, incredible accomplishment by the medical community. And it's really built on access to testing. Treatment monitoring over 10, 20, 40 years. Unfortunately, the places that most need this testing are the very places that have the most limited access. 2/3 of HIV-positive people live in sub-Saharan Africa, and while viral load tests are recommended a minimum of twice a year for all HIV patients, the majority of people with HIV in sub-Saharan Africa have never received even one viral load test. So let's talk about how we're going to fix that. Martin Hartel.
Right. So if HIV monitoring is so vital, yet the lack of it is so prevalent, you might ask yourself why this is the case and why more hasn't been done to address the needs of many people. So the primary pain point, of course, being cost. Your standard device for use in more central hospital locations is around $100,000 per device and between $25 to $35 per test, depending on location. So we designed a device for more rural clinical settings that are under raw material costs of under $1,000 and per test cost of $10 to $15. A second primary pain point is integration. So I pulled this quote from a paper on the commercialization of similar point-of-care devices, where they found that many startups and research ventures failed because they failed to address this initial integration. So to overcome that, from the beginning, we designed a compartmentalized approach that made for easier swap-and-go repairs, yet an overall integrated device to minimize contamination and, perhaps more importantly, minimize technician skills, which once again is very variable, dependent on location. So how does it work? Remember, the goal is to quantify the HIV virus particles in a patient's blood sample so clinicians can know whether treatment is working and viral load is kept sufficiently low. So it begins with a tried and true method. A clinician inserts a patient's blood sample into an RNA extractor where it is run through various solutions isolating this HIV RNA. That isolate is then placed onto a microfluidic chip where it is mixed with amplifying chemical reagents and run parallel with water to create a series of dilutions in those wells at the bottom. These chips are then placed onto our thermocycler, where effectively alternating hot and cold cycles amplify these minute quantities of HIV RNA. A fluorescent camera then captures the varying fluorescence of these wells, and from that we can back out the approximate range of viral load, and the clinician will now know if treatment is working or if medication needs to be switched. So, how did we go about doing this at such a low cost? We began by prototyping with low-cost materials such as acrylic, 3D printing materials, and liquid reagents for our testing. But looking towards the future for upscaling production, we're looking at injection molding for our plastic chips, mass producing our printed circuit boards, and perhaps the most important key innovation in expanding this necessary healthcare was the realization that many of these chemicals need to be stored at temperatures of -20 degrees Celsius, which, as you might imagine, simply isn't feasible in more rural settings where they won't have access to electricity, refrigeration, cold transport. So we found that by freeze-drying these reagents, effectively removing the water and placing them directly onto our chips, not only can we distribute a device to these clinicians, but these chips that are sterile, ready to use, and efficient.
All right, thank you, Marty. So you have the technology. However great the technology is, we have to have a way to distribute it to make it viable. So let's talk some business. Here's the ecosystem we're looking at. The key thing for any low margins, low cost device is going to be manufacturing. How do you make it and get it out to people at a cost that's low enough that you can make this a sustainable process? And for us, the key is local partners. So in San Diego, we're located very close to Mexico, as you hopefully know. right across the border is the city of Tijuana, which is suffering a localized HIV epidemic and therefore is a place we've chosen to work with local professors and doctors on implementation. Also conveniently located in Tijuana are a large number of Mexican companies that work on manufacturing medical device components for US medical firms, which means that the groundwork is already laid for us to form these partnerships with people who are already experts in the Mexican medical system, experts in the local community. And in general, this is how we hope it will go with eventually every country that's in need of these services, right? You know, you can't be an expert on the medical system of every country in the world. So in any kind of nonprofit or public benefit corporation setting, local partnerships will be key. So a quick word on our timelines. I'm running a little short on time. We're currently in a laboratory validation stage, and what we're trying to get right now is clinical trials. And in the way of that, we're going to be working on a variety of grants, as well as fundraising events like this, and seeking investors who can help us raise $250,000 to support us through a full year of clinical trials in Mexico, and then we'll start scaling up to implementation and manufacturing. I'm just going to skip this. So I'd like to take this moment to just call my team up and just give a huge thanks to both the people who are here, Martin, Chris, Caitlin, everybody, and also our whole team who couldn't make it out. You know, we've got a big team. 7 people don't build a whole giant medical device by themselves and distribute it. And of course, all the people who have helped us out along the way, the National Academy, the various grants and competitions we've won, the amazing Global Ties program at UC San Diego, which got us off the ground, and of course, the UCSD Center for AIDS Research, without whom none of this would have been possible. And finally, just congratulations to everyone for being here. Thank you so much for listening to us, and it's been a real pleasure.
Thank you.
Picture now? What's that? Yeah, the pictures, right? I'm told they're supposed to stand in this green box for a picture. Okay. Made it.
Made it. Good job.
Thank you. You made it through the picture.
Thank you.
That's it. Congratulations.
Congratulations. I got your certificate
Very nice.
here. Sorry.
Very nice.
Congratulations.
Congratulations for you. It's really very nice. Congratulations to you.
All the certificates should be in there.
Congratulations to you. It's very nice. Congratulations.
Okay. I'm sure there's a joke in there somewhere about how many engineers does it take, but we got through it. Okay, now I would like to move on to the awards for the poster session. This is the first time for such a contest at the Global Summit. More than 150 abstracts were submitted for the competition. 86 were selected, 49 from undergraduate students, and 37 from graduate students. All the posters were of outstanding quality. Would the student authors of all posters please stand up and be recognized? The abstracts were judged by a team of 34 volunteer judges. Each poster was reviewed by 3 judges. Would all the judges please stand up to be recognized? Thank you. I would also like to acknowledge Klaus Daniel of Oak Ridge National Lab, chair of the Poster Session Executive Committee, who along with the committee organized the judging. Klaus, please stand up to be recognized. The posters were judged according to 3 criteria: excellence in original research, excellence in societal or technical impact, and excellence in poster design. There is an award in each category for both the undergraduate and graduate posters for a total of 6 awards, each for $2,000. And now I would like to introduce the winners. As I announce your name, please come to the stage and wait here. We'll take a group photo. So the winner of the undergraduate award for original research is Shi Da Zheng from China, Ultra Clean, an ultrasonic and vacuum wear-free washing machine.
Congratulations.
Your certificate. Thank you. The winner of the undergraduate award for societal or technical impact with Cristavo Mario Cacome accepting for the team is, I don't have the team name here, it's from the United Kingdom Nomadic Resource Generation. Stack of them here. Congratulations. Okay, the winner of the undergraduate award for poster design is Stefan Monaran, United States Point of Care Health Informatics for Proactive Epilepsy Seizure Alert.
Congratulations to you.
Thank you. The winner for the graduate award for original research is Mamdou Mubarak for the United States, Network Design for In-Motion Wireless Charging of Electric Vehicles in Urban Areas.
Congratulations to you. Very nice indeed.
The winner of the Graduate Award for Societal or Technical Impact is Rana Soltani Zarin, United States Virtual Reality Enhanced Intelligent Upper Arm Exoskeleton for Rehabilitation of Stroke Patients.
Oh, congratulations to you. Very, very nice indeed.
And the 6th award, the winner of the Graduate Award for Poster Design is George Banis from the United States, Encapsulated Biomaterial-Enabled Microsensor for Pancreatic Health Monitoring.
Congratulations, George. Very nice.
Again, congratulations to all.
Very nice indeed.
Green box.
I think one should come up a little bit. I think that white thing can probably come off there. Yeah.
Yeah, no.
If you want to, you can open it up.
Sure. There you go.
Yeah, show that.
Okay,
Yeah.
there you go.
Yeah, yeah. That's it. That's it.
There you go. Too many of them. Too much paper. Okay.
All right. Congratulations again.
Well done. Well done. Very nice.